Hey everyone, my name's Daniel Katz. I'm one of the lead organizers of the NYC++ Meetup. Whether this is your first time here or you've joined us before at one of our other meetups, thanks so much for coming and deciding to spend your Thursday night with us. This meetup is a place for C++ enthusiasts of all stripes. So whether you are a university student or a recent graduate of a bootcamp program or an industry expert who's been writing and practicing this language for many years, you're in the right place in this room, and I'm really glad that you decided to join us. So with that said, a few things before we really get started. First of all, I am really excited to announce, clicker, that. We have our first corporate sponsor. Bloomberg Engineering is sponsoring the NYC++ meetup at the silver level. Bloomberg was also an event sponsor for us at our February meetup over at NYU. So this is really them continuing to support and invest in this meetup and New York's C++ community. And we're just thoroughly grateful for their contribution. It's really going to help us to keep these meetups going. We host about once a month, and this contribution from companies like Bloomberg is how we're going to be able to keep running these. So thank you so much to Bloomberg. Thank you. And tonight, I really need to also be thanking LSEG, our event host and event sponsor for tonight. We have LSEG to host for this delicious food outside, unless you're referring to the delicious baked goods for Orwasher, in which case, thank Bryce. But it's because of organizations like LSEG that invite us into their offices that we're able to hold these events in the first place. So again, we're just really thoroughly grateful for them inviting us here tonight in this incredible, breathtaking space that, this is my first time here. Like, my mind is probably blown as much as all of yours. So, but before we get going, I'd love to invite up Robert Leahy from LSEG. He's going to tell us just a little bit about the company and opportunities here. And also, Robert, thanks so much for helping to plan this with me.
Thanks, Daniel. I think I had a slide. I don't know where it went. Did it disappear? No, I think it disappeared. Well, I can tell you a bit about the opportunities that we have here. So I work at the low latency group at LSEG, and I've done so for about a year since a company I worked for was acquired by LSEG. We're hiring C++ developers. I was asked to tell you that and give you a bit of a pitch. So if any of you are looking for an opportunity, we're looking for people to help us write C++ code to understand the world's financial markets. We don't just have opportunities in the low latency group. We have opportunities across LSEG. If you're curious about either of those, I can give you email addresses or web links to check them out. And I was also told by people who aren't me that apparently we have a good PTO policy and people are really happy about that. So I should probably take some vacation days. Right, we do. We not only have remote positions, we have global positions. So if you want to work remotely from Canada, for example, you can do that, like a lot of the people I went to school at my alma mater with are doing right now. And if you want to work locally in one of a bunch of different countries, LSEG has offices in a bunch of different countries. And we also do visa sponsorship. That's the only reason why I live in this country right now.
Awesome. Thanks, Robert. And thanks again to LSEG for hosting us here tonight. The remote work, that's all anyone wants now, right? Just let me work for Spain, then I'll work for whatever you do. No, I'm kidding. So I think we are missing a couple of slides here, unfortunately. So I'm going to refer to some stuff that you can't see there, but we'll be posting these slides on nycpp.dev, our website, after tonight. So check out there to check out these slides and the discount codes that they contain. What? Well, let me tell you. So if you attended the April meetup over at Adobe, then you heard David Senkel talk to us about the forthcoming C++ Now conference that's happening next week in Aspen, Colorado. And I'm going to be attending myself. I can't wait. I haven't been to a tech conference since like 2018, 2017, like before COVID. So I'm really excited to go out there and hear some great talks by awesome speakers. But looking a little further forward, there are a couple of other big C++ conferences coming up that we wanted to share some information about. So imagine that there's a slide here about this, but in June, early June, June 6th to 7th, there is Core C++ coming up in Tel Aviv, Israel. So if you've been looking for an excuse for an international getaway, well, now's your chance. And Core C++ they're going to have a pre-conference event on June 5th. And then the conference itself will be 2 days, June 6th to June 7th, over 40 talks with keynote talks by Bjorn Stronstrup and Daisy Holman. So, if you're going out that way, definitely some talks you really don't want to miss. It would be awesome to catch. And just for this, not this conference, we're not a conference yet, no. Just for this meetup, there is a discount code. And there is a link that you will not remember, so I will not spell it out, but check the slides later if you're interested in this conference. 10% off the ticket face value. Airfare, hotel, obviously that's still on you, but like if you're going out anyway, then 10%, that's pretty cool. So, if you're thinking of, I should also mention if you participate in the ISO WG21, like International C++ Standardization by chance, you might be going out to Varna anyway for the next WG21 meeting, in which case, like, hey, maybe you stop in Tel Aviv along the way. Maybe you go to this cool conference. So keep it in mind. And if that's not quite your speed because it's too far, then in July, there is CPP North, yet another conference. That one's also international, but it's in Toronto. So a little bit closer to home. Toronto is an awesome city. I was there last year with my wife and some friends. We had a lot of fun. You too could have fun. Wouldn't you like to have fun? So that's going to be July 17th through 19th. It's an awesome pitch, right? And also pre-conference events on the 15th and 16th. Also some great keynotes. Kate Gregory, Jessica Kerr, Timur Domler, and Ben Dean. So if you're going out that way, again, some talks you really don't want to miss. Could be great. And they have also set us up with a discount code, which is CPP_NYC. Again, check out the slides later when I post them online. That's $250 off the price of the ticket. Pretty cool. Again, like hotel and airfare, that's on you. But if you're going anyway, $250 is nothing to sneeze at. So yeah, check out cppnorth.ca, the website for the conference. Follow them on Twitter and LinkedIn. And yeah, keep it in mind. So with that said, this meetup is for enthusiasts of C++ in this region to get together and network and exchange ideas and hear some awesome talks by people at the vanguard of this discipline of ours. And I am super excited tonight to be hosting Inbal Levi, who is going to be giving a talk for us tonight. She is here all the way from Israel, and she's only in New York for a few days. So it's awesome that she's able to talk here for us. Inbal's here on her way out to C++ Now, the conference I mentioned next week in Aspen, but we're going to get a preview of her talk right here tonight. So I feel like we're super lucky to get that right in our own backyards here in New York City, and that's one of the things that makes these meetups so cool. But yeah, Inbal is a very prominent member of the ISO International C++ Committee. She chairs the SG9 working group that does ranges. She's also active in developing reflection, which if, well, a little bit. Okay, well, helping out. Who isn't? No. But anyway, and also the program chair for C++ Now next week. So anyway, really excited to hear her talk on abstraction layers in C++ here tonight. So please join me in welcoming Inbal Levi to New York City and to NYC++.
Thank you so much. All right. Wow, how exciting. Thank you, Dan, for the great introduction. I will mention that we know before this meetup, I know Dan because we're meeting once every 2 weeks and trying, hopefully, maybe to get reflection into C++ at some point. I mean, we're just thinking of how to promote that, but I appreciate your yeah, I definitely hope we'll be able to do something in that territory. Let's see if the clicker works. Oh, well, with a small delay of 10 seconds or so. Yeah, I'll also mention I'm one of the organizers of Core CPP, the conference in Israel. So we'll be very happy to see you there if you're all welcome. Also, a great venue. Thank you. Thank you, Robert, for hosting us here. This is one of the best views I had of New York. Thank you. All right, so I'm very happy to have you all here today, and I'm going to talk today about abstraction layers. This topic is a bit abstract, and it doesn't refer to any technical term that we have in C++, so don't try to scratch your head and trying to understand what this have to do with any feature that you know, because this is a new idea, a novel idea, and I hope you like it. So let's start. Wow, it is a bit of a delay. So I think you already heard who I am. I also work at MPDG Services, which also called Millennium. And I'm involved in international conferences, which you already mentioned. I love language and software design, and I also have kind of obsessed with cataloging stuff. So maybe that affects the way this talk looks like. This talk is about abstraction layers. I want to create, we're going to, through the talk, see the creation of abstraction layers model for C++. And this is not a final model or anything along those lines. So the whole purpose here is to also get your feedback. So I really hope you'll I'm really hoping for your reactions and inputs. We're going to look at some existing solutions of what we currently have and possible future solutions to what we can do with this model. So what are abstraction layers? Before that, let's talk about what are abstractions. So generally, I think we all have a general idea of what is abstraction. We're using that in, for development process. This is what we do. And from Wikipedia, abstraction is the process of removing or generalizing data, etc., to focus attention on details of greater importance. So here's a piece of code. And as C++ developers, I'd like to hear, what do you think of this code? I'll give you a hint. It bothers me a little. Can you maybe specify what you don't like here? Like, you can shout. You don't have to raise your hands or anything. True. Yeah, Amir, yes, I also get that, but Amir got the answer that I was aiming for. Yeah, there's details here, there's pointer. I mean, we don't care about this, right? We want to iterate over something, and we want to print its parameters, its members. We don't care about the pointer. We don't care about addresses. So, and that's, to be honest, it's more like a C code, right? So this is better, right? Now we actually remove the pointer. And for modern C++, we have this. So, I mean, in my opinion, this looks good. Some people would say it's less readable. I don't think so. And for C++23, we also have a std print, by the way, just mentioning. It's a wrapper on std format. So there's additional example. We have a system that want to read data and then distribute it. So what would be a way to send messages throughout this system? Do you want to have push or pull or something else? Again, feel free to shout. And if you feel uncomfortable with this example as well, feel free to say why. Okay, yeah, we can have push. So generally speaking, there's more information that we need here, right? Like this is a nice diagram, but we need to understand like things like latency, right? We need to understand like more details about the system. Like which technology is this made from? It could be classes, it could be functions, it could be services, right? So those two examples show you an example of under abstraction and of over abstraction. And the reason I'm bringing it up is because I feel that we need to, during this talk, we need to make sure that we're going to the right level of abstraction when we build this model that we're going to build. But we also want to make sure that we're not going too much into details, because that would basically get our mind off the important stuff. So this is a quote from the former head of electrical engineering and CS of MIT. And I think that actually represents what we were trying to do here. We want to forget information that is irrelevant and remember the details that are. All right. So I want to start with a simple example talking about abstractions that we have in C++. So here's a very simple example. You're all familiar with it. We saw it before. and we're advancing the pointer, right? And we have a char array. If we replace the char with an int, and we have exactly the same code, we get different step, right? This is like familiar to everyone. So what we had here is two different layers of abstraction that we're moving between them. We jump from one to another. So we have the memory layout, the bits and bytes, etc. And we have types. This is something the language defined. Types is something, right? It's not like we're not going into the CPU level or the binary code. We're jumping between layers. Oh, sorry, something messed my presentation. All right, another example. This example is talking about if we have an int and we're taking its address and we then dereference it, we're going to get an undefined behavior. Now, the thing here is that we have three things that collaborate. We have the duality of int and memory address. We have the invalidity of the address and the UB that is created by it. And we also have a paper that addresses this non-deterministic pointer provenance. So it sounds like I'm talking about C stuff, right? And we're C++ developers. We're using modern language. But this is not actually a C problem. We have, I think, around 5 or 6 papers. The last one is the one that I've mentioned before. The example was actually from the last paper. And as you can see, this is from 2022. And these papers have been presented in the C++ committee, not in the C committee. So this is actually things that we care about for C++. And those levels of abstraction or jumping between levels of abstraction is creating bugs till this day in C++. So I hope you're now all convinced that we need to have some kind of model to deal with those sort of bugs. And now you're going to join me by building it. How exciting. So we're going to analyze the language and the library and build this layers model. We want to identify borders between layers because as we've seen in the examples, these are the things that create the bugs. And we want to recognize dangerous parts. So let's see the simple example that we saw before. I'm just reminding you that we were addressing the invalidity of the address, the duality of int and memory address, which is the type, and also the UB created by it. And I've sort of classified those things into different groups. So memory layout, this is the thing that is close to the hardware. And then we have the types and we have the layout control. I'm basically just inventing those names. There could be better names for that. But this is addressing pointers, references, things like that. And as I've mentioned, we have types, but we also have library headers that refer to types like std float and conversions and casts and things like that. And we have what I've called layout control. Again, this is a made-up term. Pointers, references, aligns, align off, things like that. Also, memory allocation, I would address it with the name memory allocation. Things like delete new memory resources. And also, next to the memory layout, I also classified things that relates to program and source code in general. So this is not like modifying the bits and bytes, but still doing something in a larger scale. So ASM, this assembly, go to source location, and linkage and modules, new thing that we have. And of course, notice that the things that are interesting are the borders between those classifications. So I'm not going to go over all of those with details, but you can see that I've sort of defined this complete model, and we have the level going away from the hardware. And these are all contains either keywords or library headers or utilities that we have. And they're trying to create a scope around each of our features. So I'm just going to leave here, the delay again. Just going to leave this for a few seconds and pause so you can just read some of them and wonder about them. And again, this classification is a proposal, so it's not like something that is final. So of course, someone may claim that I should have classified it differently, but yeah, this is how it looks like. Any questions so far? Okay, so here we have the higher level. And I think it's interesting because for different domains, we care about different levels, right? And there have been few proposals in the C++ committee and in general that was trying to basically limit the features according to the domain, or decide that we want to only use modern C++, so we never want to have new and delete or whatever. We could actually use this thing to classify features in a larger scale than we do. Like, we can tell the compiler, for example, I only want my program to contain and put in aside libraries, as Bryce correctly mentioned when we discussed it. But if you ignore the libraries code and you just address your source code, you could say that you only want your source code to contain things from this level up. Only things that are containers, ranges, iterators, this level of abstraction. You don't want now to go over and use examples as the ones that I've shown in the beginning. So again, just to scare you up a bit, this is the full list for keywords. Yeah, we have a lot of them. And this is the library headers according to the classification that I've mentioned. So we can maybe discuss it later. But now that we have this thing, we can look at pieces of code and classify them, different part of them, with different layers. So we can decide that this thing is related to types and this thing related to layout control, what I've called before, which is like references, pointers, etc. And here's additional example. And by the way, this example actually initialized, sparked the idea for this presentation. This is a bug that we have on the ranges library, and I've discussed about this in the last committee meeting. So let's say I have string stream, and I iterate over it. I get the expected behavior, right? I get 0, 1, 2. Great. Now, and please ignore the fact that those slides are like that. Now that I add the ranges layer, I create my string ISS, and I wrap it with some layer logic, some ranges logic, basically iStream view, and then I take view on top of that. And then I use the extraction operator to extract from the ISS. What do you expect to see printed for this example? Like, anyone wants to shout? Feel free to. 1, okay. Other guesses? It's a simple piece of code. This is not a trick question, or is it? I mean, we saw what happened in the previous slide, right? What we had in the previous slide was 0, 1, 2. What do we have here? Interesting. Less tries. Well, we're going to get 0 and 2. And this is kind of unfortunate, right? Yeah, I'm unhappy about that. We're going to fix it. We're going to fix it. Don't worry. We're not going to have this bug in C++ 26. But meanwhile, this example actually showing us, and again, I just want to show you that we're having papers right now trying to address that. This is the last one from quarantine. This example may be showing you some potential of this classification by identifying the different layers that the code is actually, the code pieces of the code are being classified by. So we took something from IO, and then we wrapped it with ranges. And now, if I would go over this and ask what's the classification layer of ISS, now that I've wrapped it with ranges algorithms, I'd classify this as a ranges thing. But then on the third place, we're trying to also address it again like IO. So this is what basically created our bug. We're moving the ownership of this thing between two different layers. And yeah, that's not great. So we have some existing solutions. For example, yeah. So I just wanna say, this is not a new thing, right? Like the whole point of C++ is to operate on different layers, and this is what the language is actually doing. This is great, but I feel that we may have got too many too many ingredients into the mixture, and now we get those sort of bugs. So I'm looking at those abstraction layers as a way to classify those features into domains or into scopes and identify the dangerous errors with them. So we could technically create better code. We could just decide that we're using, guidelines, and we have tools, and we enforce those, and that's how we avoid those bugs. In that case, instead, for example, instead of this direct access, we could wrap this stream with some kind of a wrapper, and then we could prevent getting this behavior. But, oh, sorry. Yeah, so up to code, I think that's the name of the talk, David. Up to code from 2021. Yeah, David gave some really good guidelines, and I would suggest applying them. But still, this is not perfect because I mean, okay, so we have existing idioms and solutions, but this creates an acceptable overhead. Like rewriting code bases is not trivial, right? And also enforcing it on large projects and multiple teams is not trivial. We all know that, okay, great, we have the guidelines and everyone are excited about them, but it never actually happened in real companies because no one is going to rewrite the code in order to fit into the guidelines. And it doesn't help with cross-boundaries code. So things like we saw, okay, there's some really good guidelines on how to use range-based for loop and algorithms. There's no guidelines telling you how to use IO things with ranges and ranges with new deletes, right? And there shouldn't be, but putting that aside, it doesn't exist. So we could also just use a different language for higher level logic. And when I say different language, I actually mean modern C++. But modern C++ is not solving all of our problems. Okay, so we sort of put aside errors because we just moved to a better, modern code. But we now need to learn a new language with each standard that's being released, right? Each standard defining, and just to show you the example, moving from C++ 98 to C++ 20 is not trivial. You basically learn the language all over again. And it doesn't provide solution for existing codes. So what can we do better? So we now have this model, and we need to apply it on our code. And we can apply logic of this logic in error messages level. So in a sense, we don't need to change the language in order to have this model in our mind when we're writing code. We write code, and we can get error messages in the abstraction level that we want without modifying the code at all, right? This is basically a hack to redefine our code in abstraction level that we want to define it. So static analysis tools, and again, I'm sorry, can classify tokens according to their layers. So this is an example of a small tool that I wrote, a script. And the script takes some kind of tokens and classify them according to some level. And now when we pass over a code, we can actually classify R in a certain level, in a certain layer. It's basically containers, for example. And then we can classify suits out as IO, and size of is coming from the types, just again, because I classified it there. And now we get different levels in the same code base. And that tells us that we may be doing something wrong, right? And this is what the tool is actually printing by classifying the tokens. So if we look at the previous example again, we now see that we have ISS and we have the classification of ranges, and ISS is being transferred into the ranges algorithm, the iStream view. And it's now being classified as in a different layer. So we get the first message, and we continue operating over it in the ranges layer. And then we try to apply the operator on top of it, and we basically reclassify it in IO. So this is the output the tool gives. And again, this is just a POC, so please ignore the fact that it's have a lot of bugs. It actually been able to identify those things. So I'm going to skip on this slide because, yeah, I don't want to full talk because we don't have that much time. But coroutines have been added to C++20. So coroutine is some function that we can suspend, right? And we have a task, and we need to implement those premise tasks and other things as well. So if we have the main, we can have a handle to the coroutine and give the control to the coroutine. This code is being called. And then the coroutine can give the control back to the main. Okay, great. This looks very similar to something that we may have in C++26, which is the async library. So async, what is also called sender receivers or std execution, is being worked on for C++26, actually been voted in Library Evolution, which is great. It actually may make it to C++26. And it does something very, very similar. And as you may guess, it actually needs some interaction with coroutines. So here, for example, a piece of code of async operations. So we have here a scheduler, and we have a sender. A scheduler is being wrapped by a sender. And we define this work. And we have the sync wait algorithm that takes senders, pass the control from the main to sync, and pass the control back to the main. And yeah, we can actually have coroutine being passed into sync await algorithm. And this is something I made sure with with the proposal authors. But it also gives us some hints about things that may go wrong. For example, what happens if the coroutine does suspend always? Now, again, I don't want to go deep into how the coroutine looks like, etc. But the point is that suspending coroutine and also giving control may not go well together. And we can basically see it by looking at this piece of code that otherwise would have compiled and worked perfectly fine, right? This compiles, this works, I guess, according to the future proposal. But we may also recognize that there's some issue here. We're hooking together two things that are not from the same world. So I'm claiming that, yeah, and let's keep that example as well. It's been given by Hannah. But I'm claiming that this tool could actually help us identify bugs. Of course, I haven't said that, but false positives are very common. Now, I'm not suggesting we're going to take this tool and classify all the tokens that we have in the program and now get errors for each one of those changes. But I am saying that they can help us. Right. So this example, for example, we have classification here and move between layers, but that example works fine. So to summarize, we have a program, and we give it to the compiler, and the compiler get us errors, compilation time errors. And then we get this code into some testing, and we get runtime errors. And later in the cycle, we may get some logic errors that are being created by false data or problems with the data, things that we find out very late in the development cycle. I'm claiming that this tool may help us get some of those errors into an earlier stage in the development process. If we could have those identifications and classifications, we may be able to identify logic errors in an earlier stage. And I think I've mentioned static analysis scripting that I've wrote that is basically trying to imitate some other tool that we have. Anyone wants to guess? What? Go ahead. Yeah. And do you want to say what that is? It's AST, right? Yeah. So yeah, basically the compiler have all this information, right? This is the AST from Clang. For this very, very oversimplified small piece of code. If you're gonna add any library here, you're gonna see a tremendous, very, very long file. But we actually have some information here that can be used in order to classify our code. It basically have all the information that we need. So I hope you can look at this and have some sense of how much information we can actually extract from the AST. So basically what I'm suggesting is to add some layer of analytics to our code. We have compile time errors and we have runtime errors. I'm suggesting some kind of a between abstraction resolution errors layer that would be able to take logic and have a reason about our code in a higher level of abstraction than compile time errors that cares about syntax issues and things like that. But still, we're gonna find out problems in an earlier stage than the runtime. And applying those abstraction layers to our model will expose the bugs earlier, hopefully. And of course, we can add those abstraction layers, not doing this by a small script that I wrote, but we can do it by adding them to the compiler or the static analysis tools or other things that can see our AST. So to summarize, we need to focus on interfaces with the user, as someone here may have suggested to create ergonomic study groups. I guess you can, you now know who during his talk from CPPCon. And I agree, this is important, but we can also address abstraction layers as developers. Better yet, address abstraction layers as the standard committee, especially when we have some kind of a proposal that we make and want to address how this proposal actually interacts with other parts of the language that exists. This is something we don't do very well. And examine every proposal not only by the local usability, but also for integration. And for some reason, yeah. And to summarize, my suggestion is to add abstraction layer error messages to our tools. Okay, thank you for listening. So I've warned you before, this is a novel idea. Sorry, Dan, you were, oh, okay. And I just want to say, it's not like I've mentioned I work in Millennium. It's not that like Millennium says that, like, it's not something that Millennium proposed into the standard or anything along those lines. It's just my, my suggestion, my ideas. So yeah. So do you have any questions about what we saw? Do you have some? Do you think the classification makes sense? Do you think it's weird? Yeah. Oh, right. Yeah. So if anyone wants to. Yeah, there's like 3 of them, I think. And thank you for listening.
Yeah. All right. Let's get questions.
Bryce, do you want to?
Bryce, you've definitely got a question.
You want to share with the class? It's fine. I saw. Oh yeah, go ahead, David. And then, what do you think?
I think it's interesting. One of the problems that we have with warnings is that they're ignored. But one of the places where this might be useful is in the Rust model, they use this unsafe keyword, and that's a token for the reviewer of the code to look very critically in that area of the code because they're screwed around with dangerous stuff. This may be kind of useful in a similar model. So if the tooling for code reviews or whatever highlights a certain areas of code like, hey, we're mixing abstractions here, foot gun, be careful. It might be useful in that context. But the signal to noise ratio is really important, because if there's too much noise, it'll be ignored and not useful. So, yeah.
I totally agree. I just want to respond to that. So first of all, I totally agree. And that's why my general feeling is not that we need to add the warning for every time we pass between abstraction layers, is that when we make, for example, a proposal for the standard, we need to look at the proposal, analyze the examples there or examples of that with other pieces of code, and identify only some of the cases and then add those into the tools. But I totally agree with you, a lot of false positives. And I just want to say one more thing. What you've mentioned about unsafe, I had this exact idea in mind in a bit of a different context, but I had the unsafe block thing idea because I've mentioned that we can basically define that our program only operates on a certain level of specific abstraction layers, etc. We could basically say this whole program operates only from containers algorithms top or whatever, just for the group that we choose. But then we can also add the unsafe block to say, but here I'm calling you explicitly on purpose because I want to do something. So that could also be kind of interesting to say here I'm explicitly mixing different, different way to see the code. So yeah, sorry. But yeah, I agree. Thank you. Bryce, go ahead. Oh, sorry.
You didn't think you had a question, but we knew you had a question.
No, before Bryce. The person over there, he was first.
I have a response to David.
Oh, okay, so go ahead. Yeah.
So the problem that we have is that we can't ever really do something like unsafe in C++ because we've made all the safe things look like the unsafe things. Like iterators look a whole lot like pointers. And like that's a huge problem for doing anything like this. And especially like in generic code, like if I just write some code that's like templated on like something that's like incrementable, like I could feed in, some raw pointers and do some dangerous stuff with it, or I could feed in some, iterators or even checked iterators. Like how do the problem is that the unsafe things look like the safe things. We would need to completely change the syntax that we use for the safe things. And we already have like we have all of the baggage legacy of all of the actual unsafe code, but then we also have all the baggage legacy of all of the the modern C++ things that are use all of the abstractions that are safe but have the syntax of the unsafe thing. So basically we're host.
And I'll just mention that Bryce is the Library Evolution chair. So if it says so. Yeah, go ahead. Sorry, what's your name?
Hi, yeah, I'm Chris.
Chris, nice to meet you.
Yeah, nice to meet you too. I guess I'm curious, like, is there any previous work in the field? When I was in college, like I read some papers about like static analysis tools. So I'm just kind of wondering, like, is there other things that are kind of doing similar things in other languages, or is this kind of a novel idea?
I haven't seen this anywhere. It could be that someone did something similar, but I haven't seen it anywhere. What we get, we get in static analysis tools, we get warnings on errors or whatever we want to classify it by, on either compilation errors, things that we do wrongly in the code that are very clear, like not deleting something that we allocated, but they're usually like what bothered me is that they're usually in a lower level, closer to like the syntax. And that's the reason I'm basically trying to get us into a higher level of logic while getting this information from the tool. That's basically what bothered me with the with existing static analysis tools. Yeah. Thank you for the question. Hi, Mike.
Hi. Yeah, great talk.
Thank you.
So I'm really curious about this from a standpoint of a code review, as was sort of mentioned, and seeing the different warnings or errors for the abstraction layers. I'm wondering, have you tested this on any, larger scale code size to see if there was a correlation between, wow, this is really complex and developers are making bugs here, or is there a plan for that to kind of test this out?
Yeah, so I haven't tested it. Yeah, it's just it's more than I mean, the purpose is first of all to have this you know, to see how people react to the idea. And I think that even if you don't take it into tools, just the fact that people would now think when they write code of, you know, we're now doing something that is a mixture. But no, I haven't tested it, and I'm definitely gonna like I'm interested to see how it. But again, I will mention that just getting those warnings is definitely, I don't think it's going to be useful. So I would think of something like taking a code base, running this tool, getting all the warnings, choose only some of them, and then rerun it on a code base and see if it's actually helpful. Any other questions, comments? Yeah.
Hey.
Hi.
Hi, I'm Kathy. I have a
Nice to
question
meet
that
you.
was like on maybe the second slide. So you had all the,
There.
I guess,
Oh, yeah,
categories that
actually
you
have
had,
it.
the abstraction layers, and at the bottom you had, I think, bytes and memory allocation. On the right, you had program. I'm trying to understand what you meant by program. Did you mean like lines of code to be executed? Because it seems like almost all of it is sort of program.
Yeah, no, I've basically meant things that are more changing the binary in a larger scale. So like bits and bytes is like if I now use a lot on top, like things like a line of things that change, like, you know, the binary in a very high details. And programming source code would be things that are addressing the whole binary in a more global way.
Okay.
That was just my idea of, but the names may not be, you know, great and representative. So.
Well, thank you.
Sure. Exactly. Yeah. Things. Yeah.
Hi,
Hi.
I'm Taylor.
Nice to meet you.
Nice to meet you.
Thank you for coming for my talk.
Oh, no problem. Pleasure to be here. Great talk. This has been kind of rattling in my head the more that you described this. The way I'm trying to figure out how to contextualize this for myself is that this almost seems like an attempt to address years of muddling that boundary between how different parts of the standard and even non-standard pieces might interact from each other. I was curious if you had, during this process, thought about ways that the language itself might help better help these components declare what abstraction layer they sit at, as a way of not just like beyond just the token-based strategy, but also to have like, I don't know, this maybe better represented in the type, maybe better represented as part of how the like API boundaries should be used, and then writing a tool around that. I was curious.
Yeah. Oh, that's a very interesting point. I guess we could have something, you know, optional we could add. But for example, one of the problems is that we can't actually modify the, okay, so currently I think there's some agreement. We can't modify syntax, you know, because that would create too much noise. So the reason I'm basically proposing this in a more you know, higher level and only in the error messages is because I don't want to start imposing any syntax change. We could have this something as an optional thing. Do you think that will help more than just pre-classifying, you know, the whole language and library? And so my question is, if we had this full classification of library and language, in which cases would you see the need for reclassifying or classifying in user-defined classifications?
The thought I had was this hierarchy, A, is one that you would have to propose and get accepted to the standard. Who knows how long that would take? But the other thing too is that like this is an abstraction based off of what I can see primarily what the standard has today or what is going to be coming out in the next few versions. If another standard comes out that maybe like modifies this diagram, maybe that could be enhanced there. But like maybe just like a third-party library that is attempting to become standardized may not have the tools to sort of declare a new space in this abstraction tree. And so my thought is like this makes a lot of sense for if you can figure out how to get the standard to agree on what that is, then maybe you can get like a compiler vendor and the people who actually implement a lot of this stuff to provide, the whole suite of tools that you need there. But beyond that, what is available to, an organization was available to other
Right.
developers and people proposing new things for the standard. Do they have to fit in this model, or do they then shove themselves into spaces where maybe they might not? You can maybe argue that they do exist in a different layer, or might break some abstraction in kind of a novel way,
Yeah.
or maybe they just do something wrong, and you want to find a way for them to sort of exist in their own space. I don't know.
Yeah.
It's just a thought.
No, it's a great comment. I now understand better what you meant. And yeah, I mean, that's an interesting idea, because I only had, so yeah, classify whatever we had in the standard, and we could theoretically mandate that for any future proposal. But clearly there's some third-party things, and they care about, getting this functionality now from, for example, the static analysis tools. So yeah, that could be a very good idea. Thank you for that. Alex, right? Or sorry, yeah. Just before we get the next one, I just wanted to thank Amir here on the front line, that he actually offered that I'll come and speak in the New York Meetup. I didn't have that idea before. So thank you, Amir. And thank you, Dan, for hosting me. Yeah, and I really appreciate it. Thanks. Yeah, go ahead.
Hey, so I go by Vern.
Hey.
The question I have this is actually the perfect slide for it, I think. The thing that I'm thinking about is something like an async generator. And I'm wondering how you might fit something like that into this, where it actually kind of touches many of these things, even through multiple levels. Because you've got a little bit of iterator, you're not quite a container, but you're probably coming out of some sort of container, maybe, depending on how it's implemented. You've got all three of the top. So I'm wondering how you see how something like that might work under this model.
So first of all, yeah, I mean, it's totally, I would love to have that. I actually have the generator in C++23, which is great. But yeah, I totally agree. Some of those things, some of the things, like, for example, something like you described would probably fit into either ranges or async, or yeah, I'd probably put it under ranges or async. But yeah, some things fit to more than one classification. And I've noticed this when I've went over the functionality that we have. I don't really have, I've just put in them in the layer that seemed to make more sense. I think what really interesting is if you put it in a certain layer, how many code snippets or code bases violate the locate, like if I put something in ranges, how many code take something from ranges and shove it into IO and make a bug out of it. And that way I'll just probably classify it in the whatever layer that creates least bugs. But yeah, but that's not trivial. Yeah, so yeah, so what I did when I actually went over the things, I actually wrote some of the things oh, sorry for that. Some of the things I actually wrote in one layer, and also added the note that they belong to a different one. I'm sorry, I can't find it, and also the screen went down. But yeah, I definitely did that. So I agree. Some of the things don't fit into a single layer, and I guess that would be interesting to see, assuming we can actually apply this model, what happens with those. Yep. Thanks for the question.
Thank you for answering.
Sure. Any other questions? Yeah, go ahead. Hello.
Have you thought in terms of just, rather than putting out all these warnings, just having a general metric of how many things are in particular levels? Because, one thing I've seen a lot reviewing people who are more junior people moving into C++ is they tend not to be familiar enough with the stuff at the top level of the abstraction. So I still see too much low-level code, too many loops with one-off errors, etc.
So unfortunately, I can't make the screen work, but I have a slide of showing, if you could, yeah, sorry. I just want to jump into this particular slide. Sorry, yeah, go ahead. I have a slide that shows exactly how many things I've classified for each topic or layer, or whatever we'll call it. I mean, I'm not sure. Are you saying, like, generally speaking, people that are new to the language are trying to do things in a lower level of abstraction? Is that what you're?
My question is really, is people working in the lower level abstraction related to the quality of the code?
Yeah, well, I agree that the answer, I mean, I think the answer is yes.
Okay.
One of the things, it's totally, yeah, definitely. And one of the things that you could do with this model thing, as in my mind would be helpful, is to define the level that you want your program to look to use. And if you do that, then if you get new developers and unexperienced developers, and they're using too low level of abstraction, you immediately can identify that in an automatic way, and you don't have to like go over the code and just see the new or whatever things that are less clear, and it maybe helps you identify that. Yeah, go ahead, David, but maybe not.
I was just going to say that I think that people can frequently use too high of a level of abstraction too. Where some fancy pants goes and uses some crazy range generic function. And it's like, like, yeah, that should probably just, have been an increment. You didn't need a whole generic, ranges function with all kinds of concepts. I don't know if this helps with that or not, but there's probably a good place in there somewhere for code. And I think it probably takes some experience to know like where that is for any given problem, but
yeah. I agree. Well, you could add additional flag and say we don't want any higher than this layer. Go ahead, Amir. Or sorry.
Got one other first.
Yeah, but thank you. That's also a good comment.
I don't have a question, more of a comment. The layers reminded me of layers in Photoshop, where you can have layers which say you've got mountains in this layer and trees in this layer, and you can hide and show turn on, turn off layers. And I've always wished that feature existed in IDEs, because I think of my code that I'm writing as this is the core logic, this is the error handling layer, this is the layer for logging, etc. And if IDEs had that kind of mechanism to do that, then a lot of other things that deal with concepts like these kinds of layers and so on could plug into that mechanism, and we'd have that sort of support to be able to visually identify things of interest. That's all, just a observation and comment.
That's a really good comment. What's your name? You haven't mentioned.
Sorry, Aditya.
Aditya. Oh, yeah. I think we've been talking maybe a different. Anyway, thank you for the comment. It's a great comment. It's actually a really, really interesting idea. I would actually like to see that. So here we have a representative from Adobe. Can you make my IDE do that? Please do. No, really, it's a great idea. It's very interesting. Thank you.
I'm gonna write my next project in Photoshop. I like that idea.
Hi, Amir.
So on moving from one abstraction layer to another, my initial thought was that promoting, like going up, should be fine and going down should not. And then I thought, no, it's like both can be okay and both can be wrong. Which then leads to another thought, it's all thinking aloud, that there might be like explicit requirements, like explicit move between abstraction layers that you should ask for, or you should say, oh, I know that I'm doing something a bit wrong, or that I shouldn't do. And there should be some like implicit conversions, like, oh, I know that I can print ranges. So from ranges to IO for some operations. So for many operations, if we want to avoid the false positives, if we describe those like implicit conversions which are allowed, and then leave only the explicit things that, oh, you should say something. And again, it's quite like thinking aloud because it's not in the language. How would we do that? But in a way, thinking, okay, let's think about, okay, we document what you do. You say, yeah, I know that I'm doing something wrong. I guess that if you put it into a tool, then we may be able to describe those things that should be explicit and those things that might be implicit and are okay. This is my thought here.
That's a great comment. Thank you. And yeah, I agree. And that definitely addresses the false positives. So I think I may have not emphasized it enough. I'm basically using errors as a hack to avoid. In a way, we can just decide that those errors are, relevant. And those are not in our tool, and in that way, we could allow or not allow specific code, which is basically what we're suggesting, without doing this explicitly in the syntax, which is, but not to say that, I mean, we could also have the unsafe or other explicit conversions that would also be interesting. Hypothetically, if we could change the language enough, which I don't think will fly, but generally speaking, yeah, it could be interesting.
Even in the tool, I mean, it's not that in the code you'll express something as explicit or implicit, but by thinking of, okay, we know that the move between abstraction layers is required. You probably can't implement a full project only in one layer. So there are those transitions between layers that should be allowed, and there are those who should warn you, which is in a way like the implicit and explicit idea.
Yeah, but in my answer to that was just don't show those errors. That's the allowed.
Sure. Yeah. I'm with you.
Yeah, thank you. That's a good comment. Yeah.
Hi, I'm Tim.
Hi, Tim.
Have you heard of cyclomatic complexity, which is like a measure of how branchy a piece of code is? Because it seems like part of the problem of like false positives here is that we're too strict, right? Any jump between the layers is immediately just going to flag something. So we're going to flag a whole bunch of fine code as being not so fine. But if we start having a metric where we can say this code is more bad than this code, and maybe we say some threshold of like, if you jump through this many layers of abstraction within a function, now we should probably take a closer look at that, right? Like we could measure it in a similar way we do with cyclomatic complexity.
That's a really awesome proposal. I would be interested to see if I run this tool and then only show warnings, errors on, starting from a certain threshold, if that's going to be a better indication. That's a really good suggestion. Thank you. Yeah, I don't know. My idea again was to go over the warnings that automatically generated and then only decide on those that are actually creating a problem. But maybe your method could actually work and do this automatically, and that would be very interesting. Thank you. Go ahead, David. And I appreciate the interest. I'm happy to see people like this.
Piggybacking off of that idea and the one about Photoshop, I'm imagining if you're like reviewing code, if every line got assigned a color, and the more red it is, the more likely there's something fishy going on there. That would be pretty useful, I think.
Plus, we have lots of code bases with years of bug fixes that are marked as bugs. So we can look at historical data to see which transitions between which categories sort of come up a lot and which don't, right? So there's a lot of metrics and data science that can be done on this. But the notion that bugs are expected at the boundaries of abstractions, when you have two different mental models, it's not a very surprising idea, just putting names to them and maybe putting in a tool, that's great. But the fundamental problem then is that we do have users of C++ having to deal with different mental models that don't always gel together very nicely.
Right.
And I do think that there is a subtlety here, right? There are some of them maybe more hardware related or more experienced folks that their mental model is the hardware. They're thinking in registers and caches and SIMD registers, right? And then all of this tooling, and it's not, the fact that most of it is about the standard library rather than the language, right? It's not, it's obvious, right? Those things are productivity hacks, right? It's just faster and easier to think in terms of iterators than in terms of the register that holds the offset from the beginning of the array. That's very different than other developers who think in those terms of abstractions. They don't use them as productivity tool, as a shortcut. And I do think that as the community, we serve both of those needs, but they need very, very different things. And a lot of the educational stuff, a lot of the way we present the models and we offer how people should think about iterators, right? There isn't a standard. There is a standard for what the standard library should be, but there isn't a standard of what are the basic concepts, what's our narrative around iterators, around containers. And maybe making that stronger would allow those kind of things to gel together more easily. It would be easier on the education level. And so the bugs would go, there'll be less bugs.
So first of all, I completely agree with you. And yeah, in a sense, at least for me, this correlates with domains, and certain domains care about certain level of details, usually, or need to do those hacks. And that's, so we had an Epoch's proposal was, there were some ideas of having the language have defaults for default defaults for different domains, or default scope of features for different domains, and they were all not well, they were not accepted very well because some members don't like the idea of having flavors of C++. They don't like the idea of splitting the language. So first of all, I agree with you. This is definitely something that came up before, and maybe we should have gone this path, but it's not currently possible because not everyone on board. But moving this thing into errors and tools is actually, allowing you to do this classification behind the scene without actually explicitly saying, we're now only allowing this syntax, because then people would be unhappy because you created the flavors and they don't like the idea. So yeah, I agree. It could be an interesting thing to see in a sense of teaching people. You should probably be in the algorithms containers layer unless you actually want to do binary modifications or whatever. Yeah. Thank you for the comment. Okay, so I think we're yeah. I mean, I can get more questions. Maybe people want to eat.
Yeah. All right. Well, yeah, maybe we call it there. Inbal, thanks so much for the presentation. Thanks everyone for coming. And got to go to the last slide.
Yeah, sure. And thank you for your time and attention. I hope you liked it.
And the most important slide at the end is
the one with the full layer.
No, the one. Oh no. Wait. Oh, no. Hold on. Maybe if I here. I'm trying to ask you for money. But I think something I don't know. From current slide, maybe? I don't know. It's on the laptop. Anyway, nycpp.dev/support. We had a QR code and everything. It looked so good. But basically, we have like a community contribution tier on our Fiscal Host website. Just like $5 a month. If anybody's like, if you find yourself like coming back month to month and just want to like throw a little something our way, it goes a long ways. Pizza's awesome. It's also not free. Corporate sponsorships like those from Bloomberg are, hopefully like our main driver for this. But if you're interested in just throwing us a few dollars, we really appreciate anything. But anyway, next month, I think it's June 8th, we're going back to MongoDB. So we're going to have another meetup then. So, keep an eye on the meetup. We'll send out another email or however the heck the meetup website lets you know. But thanks so much for coming. I hope you've had a great time. And we have this place till like 8, but yeah, enjoy pizza. Thanks.